Imagine discovering that a corporate lawyer with absolutely zero software engineering background can now build production-ready enterprise applications almost as successfully as a senior developer.
Right, which sounds completely insane.
It does, but
Right.
I mean, that is not some theoretical future we're debating today. That is happening right now, and it's completely breaking how we secure and manage cloud networks.
Oh, absolutely.
So, welcome to today's deep dive. We are really thrilled you're joining us. Just a quick transparency note before we unpack all of this. The initial summary of today's insights was generated using NotebookLM.
Yeah, but we want to be incredibly clear here. Everything we're about to discuss is grounded purely in actual publicly available sources.
Exactly. Specifically, we're diving into this massive stack of updates from A.L. Estrin's June 19th, 2026 technology newsletter.
And looking closely at those updates, I mean, a stark and honestly somewhat intimidating narrative emerges. We are witnessing the definitive death of isolated applications.
The death of the isolated app.
Yeah. Across every domain we're looking at today, cloud, cybersecurity, AI, the new architectural paradigm is interconnected. Autonomous agents.
Right.
And the sheer strain this puts on our underlying data infrastructure and, our fundamental security models, it's just unprecedented.
Which means we really need to cut through the vendor noise and figure out what is actually shifting underneath our feet this week. Because to build autonomous AI, to have these software agents running around doing complex work on your behalf, you first need unfettered access to data.
Exactly. If the AI agent can't see the real-time data, or if it doesn't understand the state of the network, it's completely blind. It just cannot act.
Right. You cannot automate what you cannot observe.
That is the foundational rule of this new era.
Yeah.
And historically, getting AI to see the data meant building massive, fragile extract, transform, and load pipelines, those ETL pipelines.
Oh, the endless copying.
Right. You're constantly copying terabytes of data from your secure databases over to your analytics engines.
Which obviously introduces massive latency. The data is already stale by the time the AI even looks at it.
Exactly.
And this is why that new update from Microsoft is such a structural shift. Azure Databricks now has native read access to Microsoft OneLake, and it's generally available.
Yeah, we are finally moving past data duplication. The AI agents are now evaluating the real-time ground truth rather than just a delayed photocopy of the data. And the elimination of those pipelines also shrinks your attack surface, right?
Oh, massively. Every time you duplicate data, you introduce a new security vulnerability. But the integration, it actually goes way deeper than just reading live data. Microsoft also announced a public preview of lake-based branching utilizing GitHub Copilot agent mode.
Okay, I found this detail absolutely wild. Let me try to break this down for you. It basically functions like a copy-on-write multiverse for your production data.
A multiverse, exactly. Yeah. An AI agent can literally spin up an isolated parallel branch of your live production data. It can then safely debug a really highly specific, messy edge case, figure out the code fix, and test it, all without ever touching or corrupting the actual real-world records.
It's enterprise-scale sandboxing managed entirely by the agent. But that sandboxing and all that real-time data querying generates just an immense amount of network traffic across disparate cloud environments.
Right. The infrastructure has to support the intelligence.
Yeah. If an agent suddenly hallucinates, or if the network simply drops a packet, the resulting failure looks completely identical to the end user. You have to know which one it actually is.
And that brings us to how we monitor these massive networks. Google Cloud just announced the general availability of Cloud Network Insights, which they built in partnership with Broadcom AppNeta.
And this is far more sophisticated than just, pinging a server to see if it's online. They're using a dual-layer approach to multi-cloud environments. First, they deploy active synthetic probing.
So monitoring Layer 3 and Layer 4 network performance 24/7.
Right. They are tracking the raw transit of data. The hop-by-hop round-trip time, the jitter, the packet loss. Even when absolutely zero human users are on the system, they are constantly testing the plumbing.
I love that phrase, testing the plumbing, because then they pair that infrastructure testing with Layer 7 digital experience monitoring.
Yes, they've integrated a Selenium browser engine directly into the monitoring stack.
Wait, Selenium? So it's not just checking if a server replies, it's literally mimicking a user opening a browser and executing JavaScript.
Exactly. It measures the full, heavy page load time.
So for the cloud architect listening right now, this fundamentally separates the application logic from the infrastructure reality.
Precisely. When your multi-cloud application bottlenecks, you don't have to guess anymore. You can instantly isolate whether the issue is, say, a flaw in your JavaScript code at layer 7 or an actual transit routing issue at layer 3 between your AWS and GCP nodes.
Plus, they natively integrated Gemini into this. You can literally just type a natural language query asking why latency is spiking, and the AI parses the telemetry for you.
It's huge. But, isolating transit issues at layer 3 doesn't really help if your metrics are permanently trapped in proprietary vendor silos.
Oh, the elephant in the room for multi-cloud observability.
Right, which is exactly why AWS just made a massive architectural concession with Amazon CloudWatch. They introduced native open telemetry metrics with PromQL querying into general availability.
Okay, I actually have to challenge the premise of this being a massive concession, though.
Oh, really? How so?
Well, AWS is introducing per gigabyte pricing here and letting CloudWatch act as a drop-in backend for Grafana. Like, natively supporting the open telemetry protocol sounds great for open source developers, but isn't this really just a trap?
A trap.
Yeah, I mean, they're making it frictionless to import open source metrics so you never leave their billing ecosystem. Are they actually embracing open source, or are they just trying to own the single pane of glass?
Well, it's a calculated business move, certainly. I won't argue that. But
Yeah.
functionally, it aligns AWS with the toolchain that engineers actually want to use.
Right.
Previously, developers had to translate open-source Prometheus metrics into proprietary AWS formats or build these really complex workarounds.
True.
By supporting Prometheus query language natively, engineers can finally unify their custom application metrics with the telemetry from over 70 different AWS services, all without running a separate translation server. Regardless of motive, it unifies the observable data.
Okay, that's fair. So we have the infrastructure completely observable, and the data is unified without duplication. The tracks are officially laid. The question now becomes, who is actually building the applications running on those tracks?
And the sources indicate a radical shift here. We're moving away from your traditional software developer. We are truly entering the era of the domain expert.
Yes. Anthropic recently published an economic study on agentic coding that quantifies this exact shift.
This is the study we mentioned at the very beginning of the deep dive.
Right, where non-technical domain experts, so financial analysts, supply chain managers, corporate lawyers, are currently achieving verified task success rates within 7 percentage points, and professional software engineers when they use AI agents to build applications.
7%. It's staggering. Software engineering is experiencing what you could call an inversion of programming value.
An inversion, yeah.
Historically, a corporate tax lawyer had to translate their complex business requirement to a product manager. The product manager then translated it to a software engineer. The engineer translated it into Python or SQL.
And crucial nuance was lost at every single handoff.
Exactly. Today, the AI agent basically collapses that entire translation layer.
And the interaction metrics in the study reveal exactly why this is happening. These domain experts, they elicit 2.4 times more autonomous actions from the AI than novice programmers do.
Because they know what they're looking for.
Exactly. A domain expert session abandonment rate is only 5 to 7%, whereas a novice gives up like 19% of the time.
Right, because the AI already knows the syntax for Python. What the AI does not know are the intricate nuances of corporate tax law or the harsh realities of global freight logistics.
Right, it doesn't know the business.
Yeah. The domain expert persists and succeeds because they know exactly what the business logic should look like. When the AI hallucinates a tax code, the lawyer recognizes the error instantly and corrects the agent.
They guide the agent through a multi-turn execution path. They evaluate the output against real-world truth, rather than just throwing their hands up and abandoning the prompt when the first code snippet fails to compile.
And Google is fully operationalizing this exact trend. They just announced new data agents built into their agentic data cloud framework.
Right, the data engineering agent. It's directly transforming natural language requests from business users into highly optimized SQL for BigQuery pipelines.
Yeah, and their data science agent, which is currently in preview, is analyzing raw data lakes and autonomously suggesting features for machine learning model development. They're essentially abstracting the entire pipeline management layer.
And Amazon is addressing that same bottleneck with retrieval augmented generation, or RAG. Building reliable ARG pipelines from scratch has just been a severe headache for enterprise teams for the last 2 years.
Oh, a total nightmare.
Right, so AWS just pushed their Amazon Bedrock Managed Knowledge Base into general availability to solve this. The infrastructure abstraction makes sense. They manage the storage and the embedding generation. But the critical feature listed here is agentic multi-hop retrieval.
Yes.
Let's break that down because honestly, it sounds like just another marketing buzzword. Is it simply doing 5 parallel searches instead of 1?
No, it is fundamentally different than parallel searching. Instead of a simple vector search that just fetches a semantically similar document, the native agentic retriever takes a complex user query and literally decomposes it into a logical step-by-step plan.
Okay.
It executes recursive reasoning.
So give us a micro scenario. What does it actually look like in practice?
Okay, imagine you ask an agent for a Q3 profitability analysis for the European market. The agent searches the database and pulls the Q3 revenue spreadsheet. It reads the data, realizes the operational costs column for Europe is completely missing, pauses its generation, constructs a brand new search query for European operational costs, queries a completely different knowledge base, retrieves that second document, and then mathematically synthesizes the two to answer your original prompt.
Wow.
Yeah, it is performing the multi-step investigation a human financial analyst would naturally do.
And that investigative behavior is really reshaping how enterprise software is consumed and paid for. Microsoft's Copilot Cowork just hit general availability, and it moves us completely away from that classic one-to-one chat interface.
Right. Cowork is a multi-user team space where human collaborators and various AI agents are all working together on long-horizon projects simultaneously.
Which introduces a highly critical financial reality for business leaders and machine learning engineers. Copilot Cowork formally shifts the paradigm to usage-based token consumption. The era of flat-rate enterprise AI licensing is effectively dead.
Completely dead, because all of that autonomous multi-hop retrieval and background reasoning we just described, it costs compute power.
Yep.
When agents are talking to each other in a shared workspace, actively investigating data without any human prompting, they are actively draining a shared tenant pool of credits. Every single background reasoning step consumes tokens.
This forces an immediate pivot for machine learning teams. They have to now obsess over prompt optimization, context window management, and tool call efficiency.
Absolutely.
Because if your agents are inefficient in how they reason, your underlying cloud compute costs will spiral out of control literally overnight.
It's a huge risk.
So let's pause and synthesize what we've built so far in this deep dive. We have unified our data lakes to eliminate duplication. We've empowered non-technical domain experts to deploy autonomous agents. Those agents are now executing multi-step reasoning, writing executable code, and interacting with live production databases.
It's a lot.
It is. And the glaring, terrifying question here is, how on earth do you secure this? How do you apply cybersecurity to a non-human entity moving at machine speed?
Well, you absolutely cannot do it with human oversight, and you certainly cannot do it with traditional firewalls. The new Cloud Native Computing Foundation white paper on identity and access management addresses this exact crisis.
Okay, the CNCF paper.
Yeah, they release architectural blueprints specifically adapting IAM to cloud-native agentic constraints. They contrast a basic pattern with an advanced pattern.
And the advanced blueprint mandates full zero-trust architecture. It treats every individual workload, every single AI agent, and every microservice as its own secure trust boundary. It completely eliminates traditional IP-based trust.
Trusting an IP address is just a relic of the past, because IP addresses can be so easily spoofed. Instead, the CNCF mandates standards like SPIFFE and SVID. Think of these as highly secure, cryptographic passports.
Cryptographic passports.
Right. Every single microservice is issued a unique, short-lived passport. Before any agent can communicate with another workload, it has to present this cryptographic proof of identity. This ensures all workload-to-workload communication is secured using mutual TLS encryption.
So we are fundamentally shifting from checking where are you coming from to forcing the system to cryptographically prove who you are right now for every single action.
Precisely. Furthermore, it enforces the separation of application code from access logic. It delegates authorization decisions to a centralized policy decision point, or PDP, based on the NIST SP 800-162 architecture.
Right.
So the agent requests the action, but the centralized PDP evaluates the cryptographic passport and mathematically decides if the action is permitted.
And connecting this architectural theory to an actual deployment, Anthropic literally just released a real-world application of this. Workload Identity Federation, or WIOF, is now generally available on the Claude platform.
Which is huge.
It is. But we have been trying to kill static, hard-coded API keys for over a decade. Why is the AI boom finally the catalyst forcing the industry to adopt these short-lived OIDC tokens?
Because the blast radius of a compromised AI agent is mathematically catastrophic.
Catastrophic, yeah.
A static API key is a permanent master key to the kingdom. If a developer accidentally commits a static key to a public GitHub repository, an attacker has permanent unfettered access until a human discovers the leak and manually revokes it.
Which takes way too long.
Exactly.
Yeah.
Short-lived OpenID Connect, or OIDC, tokens are scoped to a highly specific request, and they expire almost immediately, often in seconds or just minutes.
So even if the token is intercepted, it is entirely useless by the time the attacker tries to actually use it. Plus, it provides a clean, standalone audit trail. When an autonomous agent executes a pipeline change, you need cryptographic proof of exactly which agent requested it and when.
Right, and this mathematical approach aligns perfectly with the Cloud Security Alliance's new paper, Core Collapse. That paper is an essential read for absolutely anyone managing cloud infrastructure right now. It details the mathematics of AI security asymmetry.
The premise being that AI changes the capabilities of attackers and defenders in fundamentally different ways. Attackers use AI to scale chaos and probe vulnerabilities infinitely.
Yeah, and defenders cannot simply hire and scale human analysts to match that automated output. The math completely breaks down.
Right. So the paper argues that strict zero trust and what they term path deletion boundaries are the only mathematically viable survival strategies for defenders.
Path deletion means mathematically cutting off all potential avenues for lateral movement within a network, rather than just, monitoring those avenues for bad behavior.
Because the primary vulnerability isn't necessarily the software flaw, it is institutional lag. Institutional lag is the time it takes a human organization to recognize a threat, schedule a meeting, approve a patch, and deploy it.
Yeah, well, AI moves in milliseconds. If your defense strategy relies on the speed of human remediation, you have mathematically already lost the war.
Mathematical security and powerful AI agents are really pushing the boundaries of what is possible here. But that brings us to the final segment of our analysis today. Even with these advancements, human constraints, our available time, our capacity for deep scientific reasoning, and government regulation are hitting their absolute limits.
The technology is rapidly outpacing our operational capacity to safely absorb it.
We see this so clearly in the new ISC2 Enterprise Training Report. They surveyed nearly 1,000 security leaders globally, and the surprising takeaway, budget is actually not the limiting factor here.
Really?
Yeah, 73% of these organizations significantly increased their security training budgets last year. The failure point is what they call the operational time paradox.
Meaning organizations have the financial resources to train their teams, but they simply lack the time to execute it.
Exactly. 53% of security leaders flag severe day-to-day job time demands as the primary barrier to upskilling. Almost every enterprise says they allow training during work hours, but the reality of fighting daily operational fires means the training never actually happens.
Which is incredibly frustrating.
It is, especially because the return on investment is undeniable. 79% of organizations report fewer preventable breaches when they actually force the training to occur. Unsurprisingly, AI dominates their upskilling priorities.
And while upskilling is critical, we really must also remain grounded about where AI capabilities currently hit a hard ceiling. There is immense hype around agents replacing specialized human researchers, but the scientific limits are very real today.
Right. OpenAI just released a research preview of a benchmark called LifeCbench,
Which moves the industry far away from those basic biology trivia tests that large language models use to just guess their way through. LifeCbench uses 750 complex free-response tasks based on real-world biological workflows.
So these are not simple text queries. The benchmark includes over 1,000 multimodal artifacts. An AI model is handed messy sequence files, complex chemical structures, and dense laboratory charts.
Right. It must analyze these artifacts and make an average of 4 distinct sequential scientific decisions per task, evaluated against criteria designed strictly by PhD-level scientists.
And here is the reality check. The top-performing specialized model on this benchmark, GPT-Rosalind, only achieved a 36.1% pass rate.
Yeah, an agent can brilliantly translate a business manager's natural language into a BigQuery SQL pipeline, but it utterly fails when asked to reliably synthesize complex, multi-step biological evidence. It cannot yet replace PhD-level scientific synthesis.
And beyond the scientific limitations, we are now colliding with hard regulatory limits. Just this week, Anthropic abruptly disabled all commercial access to their Frontier Fable 5 and Mythos 5 AI models.
Right. And to present this completely objectively, this was due to an emergency U.S. government export control directive regarding an unspecified national security concern over a jailbreak technique.
The situation highlights a massive friction point in the industry right now. The government views this specific jailbreak technique as a legitimate national security risk requiring immediate containment.
But Anthropic's position, however, is that the exploit only uncovers minor, widely documented software vulnerabilities. They argue that absolute perfect jailbreak resistance is just mathematically impossible given their defense in-depth strategy.
Right, and that their model's overall risk profile matches accepted industry standards. The broader implication here extends far beyond Anthropic's specific models, though. It establishes a really powerful regulatory precedent.
Anthropic has publicly warned that halting commercial deployments over narrow, non-universal exploit discoveries could paralyze frontier AI development. It creates a dynamic where theoretical vulnerabilities can instantly trigger government mandates that pause commercial operations and revenue across the entire sector.
So, let's synthesize the journey we've taken through today's sources. We started with the necessity of unifying cloud data to eliminate duplication and latency. We explored how non-technical domain experts are leveraging that data, using autonomous AI agents to write executable code and perform multi-hop reasoning.
Yep.
We then examined why we must secure those autonomous agents using short-lived cryptographic passports and mathematical path deletion rather than human oversight. Finally, we hit the bleeding edge, the lack of human time to train, the inability of current AI to perform PhD-level science, and the sudden reality of commercial regulatory halts.
It is a profound structural shift across the entire digital landscape. And I think it leaves us with an important, perhaps unsettling question to ponder for you out there listening.
Oh, absolutely.
If domain experts can now build complex production-ready applications via autonomous agents, and we are securing those pipelines with automated, centralized cryptographic policies rather than manual human oversight, how long until the core definition of a cybersecurity architect or a cloud engineer is simply someone who manages a massive fleet of specialized AI agents?
That is a wild thought to sit with. Are we managing the systems, or are we transitioning to managing the non-human entities that actually manage the systems?
Exactly.
Thank you so much for joining us for this deep dive. It is a massive amount of architectural change to process, but understanding these interconnected shifts is how you stay ahead of the curve. For more deep dives into cloud security and AI insights, make sure you follow the show Cloud and Cybersecurity News on Spotify.
The autonomous trains have officially left the station, right?
They really have, and we are all figuring out how to build the tracks as they speed ahead. Until next time.